So methane and water react with, to form carbon monoxide and hydrogen like this. And this is a reversible reaction. Alex doesn't usually use the reversible reaction arrows, and it talks about how all reactions are reversible, which is technically true, and it's discussed a little bit in more detail in the previous example in this playlist. But basically we have this reversible reaction. And we want to use something called the Chatelier's principle to determine what will happen when the reaction is at equilibrium and we do something. So remember that equilibrium means the rate of the forward reaction and the rate of the reverse reaction are equal. So at some equilibrium, the rate of the reaction going this way and the rate of the reaction going this way are the same. Le Chatelier's principle tells us that if we disturb the equilibrium, if we change something, the reaction will do whatever it can to maintain equilibrium. So let's see what that looks like. In the first case, we add some hydrogen. So the amount of hydrogen goes up. Well, if the amount of hydrogen goes up and the concentration of hydrogen becomes higher, that will disturb the equilibrium. So therefore, the reaction will shift to the left to get rid of that hydrogen. There's too much hydrogen for the equilibrium according to the equilibrium, so the rate of this reaction, the rate of this reaction being the same. There's too much hydrogen. So the reaction shifts to get rid of the excess hydrogen that is present in the system. Said another way, it will shift to the left or towards the reactants, however you want to think about it. That's what happens when we increase the amount of hydrogen. Once we know which way it'll shift, then we can answer the next question. It says the pressure of CH4 here, well, we're going to make more CH4. So the pressure of CH4 will go up when the reaction shifts to form more reactants. The pressure of H2O, because it's also a reactant, will also go up. So it's easier to find the shift first and then determine what will happen to the two things. Some CH4 is removed. So in this case, we make the amount of CH4 go down. Well, if the reaction's at equilibrium and there's some CH4 missing, the reaction will shift, in this case to the left, to form more CH4 because we lowered the concentration of this. The reaction says, hey, we need more CH4 when this has gone down artificially, so it shifts to the left in order to make more CH4. When it makes more CH4, it also makes more water, so the amount of water will go up. However, to make the CH4, it has to use CO. So the pressure of CO, a reactant, when it shifts to the left, will go down. The last case. In the last case, it says the volume of the vessel is increased. And when the volume increases, therefore the pressure will decrease, because volume and pressure are inversely proportional. So we need to look to see here how this will affect the equilibrium. To do that, we need to figure out how many moles of each compound are on each side. So if we look at the reactant side, there's a total of 2 moles of gas, 1 mole of methane and 1 mole of water. But on the on the product side, there's 1 plus 3, or 4 moles of gas. Since there's more moles of gas on the product side, when the volume is increased, the reaction will shift to increase the moles of gas or increase the pressure or renormalize the pressure to account for the increase in volume. So the reaction will shift to form more gas, or in this case, it will shift to the right. And I forgot to mark this, but this is to the left. So this is the direction of the shift. So once we figured out that it'll shift to the right, what will happen to the pressure of CH4? Well, when it shifts towards the products, the CH4's concentration will go down. And the pressure of water, because it's also a reactant and we're shifting towards the products, will also go down. The take-home message is that Le Chatelier's principle allows us to predict what will happen to a reaction, which direction it will shift, based on stresses to the equilibrium. And the key thing to remember is that the reaction wants to maintain the equilibrium, so it will do whatever it can to regain the equilibrium, and that's why these shifts occur.